Let's say you want to prove the proposition P. In the proof by contradiction, instead of trying to prove P directly, we assume the opposite of the proposition, so not P, and show that this leads to an impossibility. Here's the general structure of the method. First, as a good practice in all kinds of proofs, write that you're using the contradiction method. Then, suppose the proposition you're trying to prove is false. Deduce something that is impossible given your initial supposition, which finally will lead you to the conclusion that the proposition is actually true. Let's see an example. Let's prove the theorem that says that the square root of 2 is irrational using contradiction. Following our method, first we will write that we use proof by contradiction. Then we suppose that the proposition is false, so we suppose that the square root of 2 is rational. We can write a rational number as a ratio of two integers, let's call them n and d, in which d must be different than 0, and n and d have no common factor. So n and d are positive integers and are in lowest terms, which should be achievable for any rational number. So since we're assuming that the square root of 2 is rational, this should be possible. Now let's get this equation and let's square both sides, which will leave us with 2 equals n squared over d squared. So 2d squared equals n squared. Since n squared is a multiple of 2, n squared must be an even number. N squared is even. And since n squared is even, n must also be even. Because if you square an even number, you get another even number. Now, if n is even, then n equals 2k for some integer k, since again every even number is a multiple of 2. Substituting it here, we get 2d squared equals 2k squared, which is 4k squared. So d squared equals 2k squared. And this shows that d squared is even. And by the same reasoning we used here, we can say that d is also even. So n is even and d is even. But the thing is, if both n and n are even, then they have a common factor of 2. Because again, any even number can be written as something like 2k over 2w, and this would give us k over w. They have a common factor of 2, which contradicts our assumption that n over d is in lowest terms. Let's write that down. N over d is not in lowest terms. Therefore, our initial assumption was false, so the square root of 2 is indeed irrational.